Hi everyone. I'm presenting our work on the panel complexity of sortition. Specifically, we're asking, is 12 angry men enough? This is joint work with Simone, Tomek, and Jeremy. We are investigating the mathematics behind randomly selected citizen panels. Sortition is the practice of delegating decisions to randomly selected citizens rather than elected officials. This isn't just theory. For example, the Irish Citizens' Assembly used 100 random people to debate complex issues like abortion, directly leading to a national referendum. Why do we need this? Because elected parliaments often fail to mirror the people they represent. Take the 2023 US Congress. Nearly 50% were millionaires, compared to 8% of the public being millionaires. They are structurally unrepresentative. Random sampling fixes this by design. This is actually a return to the roots of democracy. Already in ancient Athens, elections were considered aristocratic. True democracy meant filling almost all political offices by lottery. They trusted that any citizen could govern. Today, we are seeing a global comeback. From Australia to Europe, hundreds of citizen panels are being convened to solve policy deadlocks. The OECD has documented a deliberative wave of these institutions worldwide. Computer science has also started studying this. Most existing work focuses on selection algorithms, how to select a fair panel when people might opt out. In our work, we take a different angle. We assume uniform random selection and ask about the size of the panel needed for good decisions. This brings us to the main question, panel complexity. How many people do we actually need? In the US, we trust a jury of 12 to make very important decisions in a courtroom. But why 12? Is that number based on statistics or something else? As it turns out, it's mostly tradition. Legend has it the number 12 was chosen to mirror the 12 apostles. Our aim is to find the optimal number k that guarantees a panel which represents the population's will. We tackle two issues in our paper. Beyond the intuition so far, what does it precisely mean for a panel to be representative? Second, we apply that definition to two specific social choice problems, facility location and participatory budgeting. Our first setting is facility location. Imagine we need to place a hospital. Everyone has an ideal location, QI. We define a panel as successful if the location they choose to minimize their own travel distance is also a good location for the entire population. Our second setting is participatory budgeting. Here we have a budget B to split among projects. We assume citizens have Lipschitz preferences, meaning their happiness changes smoothly as the budget shifts. Again, we ask, if a random panel optimizes the budget for themselves, is that still good for everyone else? In our paper, we also consider another deliberation model called approximate core stability and introduce a new definition of representativeness using the Wasserstein distance. We look at the distance between the panel's distribution and the populations. Our main theorem proves that moderate-sized panels can indeed approximate the will of the people. For full details, please check out our paper. Thanks for listening.